Hello dear students, today we are going to discuss the grouping of capacitors. Grouping of capacitors. Okay, now what does it mean grouping? First of all, understand the meaning of this word. Grouping simply means accumulation. Okay, so here it is arrangement. Okay, so the grouping is of two types. This grouping of capacitor is of two types. Okay, so first one is series grouping and second is parallel grouping. Basically they are of two type only, but if we want, we can say that there is a third type also, that is mixed grouping. So mixed grouping means again combination of, that is combination of series grouping and parallel grouping. Okay, now so here first we will deal with the series grouping. Please take a note here that grouping of the capacitor is very important from derivation question point of view for the +2 exam 2021. Okay, derivation part. Okay, numerical maybe there, may not be there, but see the marks which are assigned to the derivation, they are 100% sure shot marks. Okay, now first we will deal with the series grouping. So what is series grouping? When moving in the circuit we pass two or more than two capacitor through a single path, then that grouping is called as series grouping. Now, first of all, we should understand with the help of some example. Okay, so examples of series grouping. Okay, now consider this C1, C2, C3 when joined by a battery. Okay, now when we move from C1 to C3, or when we move from point A to point B, then to reach from point A to point B, we cross C1, C2 and C3. We cross C1, C2 and C3, or we pass through C1, C2 and C3 by single path. Okay, but please take a note here that A to this battery Z, A, Z and B, that will not be considered. While passing, we should pass through the capacitors. Okay, now I will give you another example. See this one, C1, C2, there is a battery, then again here is a battery, and here is a resistance, and the circuit is closed. Okay, now again follow the same concept. Suppose this point is A, this point is B. Okay, now this C1 and C2 will be in series. Why? Because if we cross point A to B, then we have to pass the capacitor C1 and C2 once and only one. Or if we say here, the same example, if we say that from A to point D, then again C1 and C2, when we pass from A to D, we have to pass once each capacitor to reach from A to D. We can't say that we can go via this way from A to D. That is also a path in the circuit, but we have to cross to know whether the capacitors are in series. We have to pass through the capacitors. So when we cross from A to D, we pass through the capacitors C1 and C2 once. So which indicates that they are in the series. Okay. Now take another example. Suppose this is again a battery. This is again a battery. This is C1. This is a battery. This is a resistance. E1, E2 and E3. Okay. And if this is suppose C2. Okay. Now if we pass from, suppose we pass from this point A to point B. Now there are two ways. This is one way and this is another way to pass from A to B, or to pass, if we take a full round, suppose A, B, B, A, then also we will pass the capacitor once, but here they will not be in series. Why? Because there are many intervening circuital elements like the battery or resistances. Okay, I hope with the help of these three examples you are very much comfortable that what is in series. Now if we compare the first example with the third example, then what will be there? See, these C1 and C2, in between C1 and C2 there may be two ways, and here if we go via this way, then a battery and a resistance is there, and here via this way two batteries are there. But in the first example, if we cross from A to B, we cross or pass the three capacitor each once. There is no interfering circuital element like battery or resistance. Same thing is here in the second example. So I hope that with this example the series grouping is clear. Okay. Now we will understand few more concepts of the series grouping. Suppose this is first capacitor, this is second capacitor, this is third capacitor, okay, and a battery is placed with the EMF of E, okay. So as a consequence of this, if a potential difference of V appears across all the three capacitors C1, C2 and C3, then what will happen? The first property in series arrangement is that in series arrangement the charges accumulated on the three capacitor will be same, okay. So the charge accumulated on the three capacitors will be same. So what does it mean? It means that if here charge is Q, here also the charge will be Q, and on this one also the charge will be Q. So the charges are same in the series combination of capacitor. Now when we see the potential difference, so what does it mean? If this is V1, the potential difference across C1, this is V2 and this is V3. So what happens? The potential difference are different. The potential difference are different in each capacitor, okay. So the first and foremost basic point is that, I'll repeat, in series arrangement the charges accumulated on three capacitor will be same each, okay, and the potential difference are different in each capacitor. It implies V is equal to V1 plus V2 plus V3, okay. Now we can write the charge Q divided by the equivalent capacitance C equivalent is equal to charge Q divided by C1 plus Q divided by C2 plus Q divided by C3. It implies 1 by C equivalent is equal to 1 by C1 plus 1 by C2 plus 1 by C3. Now in general, for a series combination, 1 by C equivalent is equal to summation of 1 by Ci, I is equal to 1 to n,